Our next speaker will be Renée Rondeau from the Colorado Natural Heritage Program at Colorado State University.
Thank you all. I believe I was just told I'm going to be archived. Wow. Okay. So the vegetation doesn't lie. These are not alternative facts. This is the real thing, just in case you were wondering. And hey, thanks to Nate for setting this up. Hopefully everybody got to see it. He really set the stage for this whole project. And I get the lucky job of presenting the success story of how this works. And before I dive into it, I want to acknowledge my co-workers here, Gary Austin, just retired from BLM, and Susie Parker with the U.S. Forest Service, both in Gunnison. So as Nate said, we are in western Colorado in the Gunnison Basin, upper Gunnison Basin, and the stars on this right-hand graph represent the monitoring transects as well as where many of the structures are. So for any restoration project, we should be asking this question: how do we measure success? How do we know whether we succeeded or whether we failed? What do we need to do to make success? And so our Gunnison Climate Working Group, that large collaboration of partners, asked this question, developed a management objective, and that management objective reads like this: increase the cover of native wetland species by 20% in the restored portion of the treated properties between 2012 and 2017 compared to untreated areas. Simple, straightforward, measurable. And I'll get back to that at the very end. So methods, straightforward methods, and what we have here, we stratified the site so that we have transects all along the reach, and we are measuring about 20 to 25% of the structures that Nate talked about. Nate mentioned there's about 12 different structure types that we have out there. If our randomly selected sites, transects, did not get all of the structure types that are out there, we would actually manually select it to make sure that we were measuring all structure types. We selected at least 3 controls, no structures, within each reach, often ideally upstream of the structure's influence. Once we're in the field, the measurements took place before any of the structures went in, and we established a permanent bank-to-bank transect near the structure, either above the structure or below the structure or in between the structures. And we collected foliar cover data by species every half meter using a line point intercept method. And for ground cover, we only scored it when there was no foliar cover present. In addition, we wanted to have repeat photos, so we took 3 photos, at least 3 photos from each site. You saw some of those in Nate's talk, and you'll see a few more of those in my talk. And for data analysis, we kept this simple because our management objective is simple. What we did is we classified each species into one of the following categories: obligate wetland species, facultative wetland species. Those 2 categories we lumped together, and we call those wetland species. And we also have upland species. In addition, we tabulated species composition shifts over time. So, are we successful? Let's look. Here's a string of one rock dams. This is the first site that we did on a piece of private land north of Gunnison. And these folks are building one rock dams. This site has about 53, 55 one rock dams in it. So Nate showed this. If you didn't get to see it, I'll show it again. This is a one rock dam. This is, as Nate said, one of our most popular structures. We use this a lot. And Here it is in 2012, and what you can see is the white polygon delineates the wetland area in 2013. The One Rock Dam goes in, and by 2017, the One Rock Dam has disappeared. And it's not that we went in and took the dam out. Those rocks are still there, and the sediments built up, the water slowed down, and the vegetation moved in, and you can see from the white polygon that we now have a much larger wetland. So because we take wetland species cover, this is a graph associated with a transect associated with this One Rock Dam, and it started at 90% cover of wetland species, and the trend is upwards between 150 and 180% in the last 2 years. So here's another site. The wetland species, this is that first site we worked on. This is at the end of 53 One Rock dams, basically. And the person standing in the middle of the picture, he's right above where a One Rock Dam is going to be set. And 2012 was a very dry year. You can see this from this photo. And you can see a lot of bare ground in this photo. And we built the structure soon after this photo was taken. And by 2017, does it look like the same place? Hardly. It went from 13% cover of wetland species when we started to 121% cover of wetland species last summer. Huge change. I hardly recognize the place when I'm out there. Nate alluded to these medialunas. These medialunas are set to spread the water out. This is a much wider floodplain here, big meadow. And our goal was to take this narrow wetland that's delineated in the white polygon, and it had been entrenched, and we really wanted to spread that water out. So several medialunas were built in 2012, in the fall of 2012, and this is what it looks like in 2013, 2014, 2016. So by 2016, 2017, 85% of that wet meadow is now in wetland species cover. And that just and that happened very quickly, and that's just a few structures. Nate also talked about head cuts. There's a lot of head cuts. It's a common theme out there is that we see head cuts, and we need to treat those head cuts. Bill Zedike will call that preventative, but if you do not treat those head cuts, all the other work that we do may not matter. And there's a lot of different ways to treat the head cut. The example here is the one that Nate said as we built a log and fabric structure in the upper right-hand corner. Bill is standing in that head cut. You can see it's pretty deep. We built the log and fabric structure in 2013. And what you see here is that on the left-hand photo, lower left-hand photo, Gay, her waist, I have a white line there, Gay's waist is below the bank. And Nate said we build a preventative structure to stop that head cut, and then we build another structure right below it, often a One Rock Dam, or in this case, maybe a One Rock log. And that is to, again, slow that water down, pool that water for the time being for a short period. The sediments come out, and when the sediments settle, what happens is the bed increases. And you can see from the right-hand lower photo, Gay is now, her waist is above the bank. So it's about a foot accumulation of sediments. And this head cut was moving about 3 feet per year. And they had tried to stop the head cut. The Forest Service had put some structures in many years ago, and it didn't work. This is working. And we saw this also plug and spread, and this is built by machines. And it looks good. This is a sea of sage. It's a great example of the sea of sage that we have with this ribbon of green. And while it looks great, if you were to walk it, what we would see are these incised streamlets throughout the area. And the goal was to put that water back into the main channel and spread that water out. And so the sagebrush, 1 year after these plug and spreads were put in, the sagebrush is dying, exactly where it had increased because we had downcut that channel. Okay, so just to give you an example that the vegetation does not lie, these photos were great, but is it real? So we've collected some data. What I'm going to show you here is this is a wetland species cover from that private ranch. And it started out at 15% and ends up at 85% in 2017. And this is what the control looks like. It started out at the exact same 12% cover, and now it's 27% cover, so it did increase, but nothing compared to the treated areas. We put a second layer of rock on many of the structures in 2016, and that clearly has really spread the water out even more. 2012 was that driest year we had. 2017 was the wettest year we had, so incredible bookends, perfect for monitoring. But that's why we want those control structures. So the question then becomes, let's just take all of the sites that we built in 2012 and ask the question, what's the net change in wetland species? And between 5 years and 4 years post-structure. So this first one, here's our treated one in that private ranch. You might not be able to read that, but that's a 487% increase in wetland species cover compared to the control of 120% increase in wetland species cover. Wolf Middle Fork, 200% increase in wetland species cover versus none in the controls. Wolf East Fork is, I believe that's 61% cover versus 9%. And these Media Lunas that I showed you, it's a 240% increase, and there's no control for that. These are the structures that were built in 2013. We see a similar pattern, not quite so high yet, so time does matter. And everything from 43% compared to the 9%, 41% compared to 34%. So I want to point out, not all sites are acting like we want them to act. There's no difference between the control and the treated area. This is the beauty of us all monitoring either the rock structures or the vegetation. We detected some changes that we need to make in our rock structures. We've made those, and we predict that we will actually start to see an increase here soon. You see another one right, right here, flat top exclosure. It did not increase, but that was built to stop that head cut. That's that big log and fabric. It was not built to increase the wetland species, but to stop the head cut. And so we haven't seen any change in that. 91% in another site right next to that. So the next question we ask is, what's the species composition doing? Is it changing or is it the same? So this pie chart on the left-hand corner here is what it looked like in 2012. Upland species are to the left. The black wedge there represent the wetland species. The icons there represent whether it's a forb, a graminoid, or a wetland shrub. And so you can see Kentucky bluegrass and western wheatgrass dominate the system in 2012. And this is what it looks like in 2017. I scaled the chart up to recognize that overall plant cover increased 297%. So that's a much bigger pie chart. And you can see the species composition has shifted. Kentucky bluegrass and western wheatgrass no longer occupy most of the site. But now we have a lot more wetland species cover and species. So there's twice as many species in this pie chart on the right-hand side, 14 in 2012 and 27 species in 2017. And the wetland species increased from 5 to 12. And wetland species increased 487%. And bare ground, which I'm not showing you here, but that bare ground disappeared. It went from 35% to 2% cover. Yep. So the question then becomes is, what's going on in terms of trend every year? And so we'll just look at 4 sites, and it just keeps increasing. Here's our 4 sites that we treated the first year. Increase, this is our wetland species cover increase. So you can see there's an upward trend. Where this stops, we don't know. When it finally stabilizes, when it finally reaches the max, we still don't know. It just keeps getting better. So in summary and conclusion, hopefully you all agree with me that this has been a huge success. I mean, our partners, our funders, have really just been so pleased with the results. And I'll bring us back to that management objective. We hoped to see a 20% increase in wetland species cover, and yet we far exceeded that. We set the bar way too low, which I guess is good, but it's just doing much better than we ever expected. So Bill Zedike really has this incredible eye for designing. He shared that love and passion and ability to read the landscape, and now Nate and many other folks have learned how to do these structures, learned how to read the landscape, where to put the rock structures, which kind of structure to put in. And it has really led to the success, and I've been the lucky one to actually get to monitor that. And so the photographic evidence and the data that I just presented to you that Gay Austin, Susie Parker, and I collected has really been instrumental to our funders and partners. After 5 years, our wetland species cover and richness just keep going, which is fantastic. And maintaining controls is a challenge for us because we want to treat everything. We can't stand it that there is a head cut or a incision. But these controls are really critical that we don't treat everything so that we can really detect a difference between weather and control and treated areas. 5 years of monitoring is probably the bare minimum for this kind of monitoring. And I recommend even longer if you put a second layer on, because we see a big spike after that second layer. So maybe an additional 3 years. And lastly, I really want to thank the Gunnison Climate Working Group, an amazing collaborative group. It's one of the most satisfying things I've ever done. And I thank you, and I think I have time for questions. Yes?
Who's funding your monitoring?
The question is, who's funding my monitoring, our monitoring? That is a big thanks to many of our partners. So it's BLM, Forest Service, CPW, Great Outdoors Colorado, Wildlife Conservation Society. It's a suite. And so, you know, how you divvy up all that funding is we have a whole coordinator. Tom Grant is our coordinator right now. Betsy Neely was. And so it's a art, if you will. So thanks to BLM and Forest Service especially. Okay. Yeah. Oh. Absolutely. So the question is, are the methods available so that it's somebody else could do it? Yes, the methods are available. We have them in right now. They're in reports. We are working up a publication right now for this. So we'll have a draft publication here soon, but the methods are in some of our reports that are online. Yes? Okay, so the question is what started those head cuts? What gets a head cut to go? I'm not a hydrologist here, so I'll take a stab at it, but basically, there's some kind of a nick point. There's something that happens, either a road cut, as Nate showed, there's roads coming in here. It changes the water. It changes the pattern of the water. And it could be trailing from livestock. It could be trailing from wildlife. There's a lot of different things, but it's something that's all of a sudden causing that water to go into one place rather than spread out. And when that happens, it moves upstream. Okay, so is it grazing management? That is not the only reason why you can get a head cut. And I was just given the time's up, so thank you all.
Thank you, Renee.